take you. I'll wait as long as it takes you. You will say you need me, say you don't believe me. You can try but you will never, never, never leave me. No one understands me, too scared to command me. Walking through an empty underworld of demons dancing. No one understands me, too scared to command me. Walking through an empty underworld of demons dancing. I'm too late to walk it alone. Too late to say I don't know. Too late to turn back time. All inside the I'll drag you into my home. Lose you deep in my thighs. Fall inside the rabbit hole again. I'll drag you into my home. Lose you deep in my thighs. Fall inside the rabbit hole again. Rabbit hole, rabbit hole, rabbit hole again. Rabbit hole, rabbit hole, rabbit hole, rabbit hole, rabbit hole, rabbit hole again. I will always wait for you. I'll always be waiting. I will always follow you, 'cause you cannot escape me. I will always wait for you. I'll always be waiting. I will always follow you, 'cause you cannot escape me. I'll drag you into my home. Lose you deep in my thighs. Fall inside the rabbit hole again. I'll drag you into my home. Lose you deep in my thighs. Fall inside the rabbit hole drawing me in and I want to get close. Get so intense like I'm lost in an ocean, drifting away, feeling exposed. Don't wake me up, I'm losing my gravity. Leave me now, I'm losing myself. Don't wake me up, I'm losing my sanity. Leave me now, I'm losing myself. I'm losing myself. I'm not the same or given. I've played this game no one wins. Pulling me through is this strange kind of motion. It's drawing me in and I want to get close. Get so intense like I'm lost in an
Hello.
drifting away, feeling exposed. Don't wake me.
How's the level of the audio? Okay, it looks good. Alright, we're gonna finally try and get this joint system working. So I got a little bit of a change. I got it to completely stick together, but the issue, as you can see here, is that it stops moving. So I created this new code where it actually links them together and does a second movement step. So it's a little bit more expensive, twice as expensive, but I think that's worth it for joints. And then I was trying something here, making the movement turn into the cross. Basically the idea that the only way it can move, the particles can move, is across the tangent of the connection, of the joint connection. So it transferred their velocities to that. But the issue is that there's actually two joint connections for each. So I need to find a different way of doing this. And the interesting thing is here, this code with the velocity adding and subtracting right here, it's the same as well as up here, it's just with the adding. So yeah, you can see it swings a little bit, but if I add the 10 joint strength like I did the other one, you can see it actually swings. So that's cool. I don't know if that's going to work the way I want it to work though. I also don't think it takes into account mass at this time. If this is heavier at the bottom, I don't think it's going to change anything, and I think I need to fix that. The other thing is it's really hard to move them all. With this system. See, they get tangled up really easily. Yeah, that's an issue. Maybe I should find a better way of moving this too, because it actually works well when it starts from the beginning here. What I'm guessing is that the way I'm transferring the velocities here is wrong. I don't know. Try increasing it to an insane amount, like 100, see what this does. Oh god, okay. So actually, what is the gravity? It's just 1 per second, so... I'm wondering how much the joint strength is dependent on gravity and that other stuff. Yeah, you can see as it gets stronger, it completely bugs out. Creating a game engine from scratch. Yep. Mostly. That works alright. Cool, can it build to WebGL? Nah. It's just for PC games. Interesting. So when I pull the one way with this, it actually causes the spring to jerk back, which is a huge part of my issue here. It's also not like a normal engine. It's made in C, and it's janky as hell. It's really only for me. Oh yeah, man, this should still swing more. Alright. How would this take into account weight either? Would one... I guess one would pull on the other more. I'm gonna try adding mass to this. So I'm just gonna do the scale of one mass to the other. So then multiplying by this. Wait, is this correct? Okay, so if this is twice bigger... Okay, it's actually the other way around. This is LMAS 2, this is LMAS 1. Alright, now I need to make the masses different. So I'm going to make the bottom one 10 times heavier. Mass of 10. Oh wait, that's actually the top one. 0 is the bottom. Oh! Oh my god! Okay, that's okay, that's so funny how it hits the ground and then it pulls it back up. Are there no compatible libraries for 2D gravity? No, I just want to make my own 2D physics engine so I have more control. I also want to do custom colliders so that I can do procedural scenes. This is really weird. The velocity shouldn't, at least I think the velocity shouldn't be overpowering. Sounds like a lot of work. I've done a bunch of this stuff before, so it's not that much. I like doing it too. Joints specifically here are really tricky. I have a really specific way I want the joints to work. I want them to stay together and not be like normal spring joints. But the issue is that spring joint mechanic is how you get the swinging mechanic as well. And I'm at least going to need a little bit of the springiness if I want elasticity, but so this should be setting the position. Update, transform. Maybe because I'm not calling update transform. Oh, you can see it teleporting up there. Oh yeah, it's the way the rendering's working. So it's teleporting up there, but then the velocity is going so high. It's not. Damn. Alright, so I gotta increase the joint strength a little bit. Oh god. Wait, that was really weird. They actually left. Oh my god. Huh. So multiplying this by 2. Okay, it's obviously the bottom one actually where it does it by 20. Except it's not right there. It also happened. Wait, did I change something? It can't just be multiplying this by 2 because I'm also scaling it by... Oh, it's because I'm adding the position there. Oh, okay. Okay. Mass undeclared. Oh, it's L mass. Ooh, no, that's a really bad effect. Yep, so this isn't going to work. This is still relying on the same spring method. So I'm going to look at doing what I was trying to do before and transferring the velocity into the tangent movement, or the movement along the axis of the connection, or the joint. That was better there though. Let me see if I... No, actually that wasn't good. It's got a gap in it. That's going to be the difficult thing too, is how do I take into account mass? I guess mass is more when the velocity is transferred between them. Right here. Wait, actually, where do I do that? Right here. I'm also thinking I don't have enough control in this like joint test, because doing this is super janky. That actually looks so good right now. I do like the way this system is working, the way it holds together, even if you, no matter how hard you pull it apart, it keeps the joints together. Now I just want to get it to swing. Gotta take all their physics into account, can't leave out mass, yeah. Yeah, I do want to be able to have like a wrecking ball mechanic where there's like a big heavy thing at the end. I think I'll have to see. So is that with a bit of viscosity there? Yeah, so viscosity makes it way stiffer and swing less. You can see it like up there moves more. Whereas when I set viscosity down, you can kind of tell up there moves less and it swings a bit more. Yeah, it's not conserving velocity correctly though. You can see it's actually swinging down the first time correctly, at least I think so. But then right there when it goes through the bottom swing, it's not gaining the velocity to go back up. Yeah, one of the tests I was thinking of building is like a little, holy shit, why is this song so loud? Building a little like race car game where it's two of these circles connected. This is looking pretty good though. It's like, if you see, it's not like getting caught on each other and glitching out like before. Also, I want to see something. Right now it's not completely, when I drag it, it's like direct, it's adding to the position. It's not actually setting the position, so when it moves, it ends up not matching up. So I'm going to see if I can change this drag function to set it. No, even right here, I'm adding to it. We'll check back later. Keep up the good work. Thanks. See you around. Now you can see what I'm doing right here. I'm adding to it. Alright. I don't even think I'll need the cross, but maybe I'll try adding this. So I'm going to see if I can do the same thing here, but adding less. Oh my god, actually, it should transfer this velocity depending on where it's pulling. Okay. I think I'm starting to figure this out. You know what I haven't done either? I haven't benchmarked the sinf function or cosf. I really should do that. I'm going to do that right now. I'm going to test it compared to a triangle wave, I think. Alright, let's try it with triangle wave. I'm just wondering, because sine is actually something I could easily map more efficiently, I believe. And I need to output the results here, I forgot, just so that it's not optimized out. Alright, there we go. Oh my god, how did I not realize that? I'm like, what's wrong? Oh, that's very fast. Let's do more. So 100 million sine function calls in 2 seconds, 100 million triangle function computations in 3.8 seconds. It is actually incredible how fast sine is. So it's faster than an mod and Fmax calls. I am very happy with that. I've never tested that before. I've heard people implement their own sine and cosine functions to be more efficient. I do not think I could be more efficient than that. Anyways, so what I believe I have to do is, I think, well, first of all, I think I'm going to rewrite a lot of this because this is a mess. But I'm going to keep this base movement of moving them together. What's weird is from my calculations, I should multiply this by 0.5 to put them together. But for some reason I don't need to. For some reason they go together fine, just... Because the whole thing is if they're both moving by this distance, then they don't need to both move the full distance, they both need to move half and meet halfway. It doesn't make sense that they're both moving Oh yeah, and I was also adding the velocity to this. I'm gonna experiment with that. I forgot I was doing that. So that'll change a whole bunch about this. Or at least it should. Whoa. What did I do? What is that? It's like a worm. Oh my god. Oh, it's just adding the one velocity. Try them moving halfway. Nope. So it gives it springiness. Alright, now let's try the movement. Or adding the next movement step to the distance calculation. Okay, it's hard to tell if that even did anything. So that keeps that one more connected right there. Yeah, so I don't think that does anything. Alright, I'm pretty sure I have a good idea of what I need to do. So, before I was talking about calculating the tangent or whatever with the cross product, and then that is the direction or vector that the particle can move along with the connection. And then I was basically normalizing the velocity to that, scaling it up by the length. But that's not how it actually works. What it should be doing is it shouldn't constantly transfer the velocity across to that. For example, instead it should work the other way around. It doesn't shift the velocity of the axis it can move on. It instead stops the velocity from moving anywhere except for across that axis. So for example, if it pulls downward, it should, instead of doing this stupid viscosity system I have where it linearly interpolates, it should actually calculate that it's pulling and then transfer that velocity, that pull, up to the next one on the joint. And then of course if it's traveling across the tangent, it doesn't have that pull. Alright.
Tell me that you read my letters. Tell me that you heard my songs.
So I think what I'm going to do is I'm just going to normalize this instead of doing that force calculation there. I'm going to take all of this and I'm going to put it down here as old. Alright, so I'm going to rewrite this. Alright, so I'll calculate the tangent now. Calculate the dot product of the velocity versus that. So I'm going to need to normalize both velocities. I'm just looking. I could actually, yeah, I forgot. I still have to go through and optimize these. I still just wrote this stuff all quickly for testing. I'm gonna go and finish all this joint stuff first, though. I just need to remember that this isn't finished. I can't just delete these comments and I'm good. I need to actually refactor. Actually, probably not refactor too much. Just. Anyways, now that we have the normalized velocities, we can calculate the dot product between the tangent and that. So now I'm somehow going to need to well, one thing I'm always going to do is I'm going to apply that apply the movement, but this is all about the velocity transfer. So if this is 0, it transfers full velocity. If it's 1, it's already moving in a good direction. So like my whole thing is as well, I'm wondering if it pushes down or it pulls down transfers to the top. Anyways, I think I'm gonna keep this old code. I don't know. Oh man, what's the next step here? Actually, do I just need this one's velocity? Alright, so I think I have to do the inverse of these as well if I'm going to be lerping. Okay. So I think this velocity is now going to be so if it's 1, there's no change. And then it also adds the opposing based off that as well. Alright. Oh yeah, and I should multiply these by the length so that I can just use Alright, sweet, now I can just multiply each of these, and they'll automatically do the length. Okay, let's see what that does. Oh yeah, it's V1, V2, oops. Whoa. That's weird. Oh yeah, because it's not connecting them either.
Did you really think that you could just fix it like that? Coming over here, trying to feed me your version of fact. Just how long did you think that you could fake it? Can't hold on, we already started breaking. I'm not yours, so stop acting like you own me and know me. No, you're never gonna show me. I'm so beyond being hurt and heartbroken. I'm too far gone, I just can't even hold on. No, I know I should have stopped it when I noticed your eyes. Look at how they lie. Your eyes, they lie.
Alright, so this will at least keep them together. That's interesting. It makes a really stiff joint. Oh man, look at that. That's like, it's like molasses kind of. So now what it has to do, so part of the thing with this is it's taking all the velocity away as it moves down. It needs to transfer this velocity into the tangent movement. So first thing I'm going to try is adding this dx and dy to it. So it has that bit of springiness, and it also gets slowed down. It falls. Yeah, so no, that doesn't do it. Alright, it's looking good though. This is actually this is really promising, I think. I'm pretty sure all I need to do here, now that I have it slowing down as it falls, like this slowing as it goes here is the proper, basically like the force getting pulled up here. Now I just need to make it so that when it gets pulled up here, it transfers it into the tangent velocity, so it keeps swinging up, hopefully. Hey, GRFI. Grift. Do you want me to call you Balkan? I'm just going to call you GRFI. Made some progress? Kind of. So, the thing I was doing yesterday was way too elastic, and everything could get pulled everywhere, which I didn't want at all. So now I've got this approach where it stays stuck together. No matter how far away I pull everything, it stays together. But the issue is it doesn't swing because of how stiffly it's held together. So this approach is like way better because it's actually stable and doesn't get pulled apart. Or it's moderately stable. But then yeah, it doesn't swing, which is what I'm trying to solve now. But as you can see, it's staying completely together, which the other one used the spring. Like you can see when I pull it, it goes apart. But as far as I'm aware in the actual physics calculations, it gets teleported back here instantly. So like this is just the rendering when I'm pulling it. But yeah, my idea, I actually think I'm going to need to save this dot product result. So I mean, the sign of this dot product will give me the direction of the normal or the tangent. So then I think normal x, or actually tangent x, what am I thinking? Tangent x times the dot product here. So if it's facing the tangent, oh, this should actually be inverted. So this should actually be the inverted times okay. So the inverted, and then I need to copy the sign from this dot product. Ah, man, actually, I feel like this still won't do what I want. I'll have to see. Just thinking about what it's gonna do though, I feel like changing the velocity to the tangent is gonna be too much. I don't know. Whoa, yep, it's too much. That's too much. That's so cool though. It's still kind of holding together. Oh my god. Oh, Jesus. Tiny bit too strong. Yeah. Oh my god. You know why it's too strong? Oh wait, never mind. This is normalized. I feel like I almost need to calculate when it gets pulled down here and it's being pulled, it turns that into angular momentum. Like the velocity along here gets transferred into angular. I don't know how to calculate that pull. Well, like I guess when one pulls on the other, it transfers it to angular momentum. I just don't know which way I should do it. So you can see it actually still does the falling at the beginning correctly, and then once it starts going around here to the other side, where it starts adding up the velocity, it goes way too high. And it's actually adding it way too much in these taller ones, which is really bad. It's actually supposed to be adding more velocity in the lower ones here. At least to keep it swinging properly, I think. What if I just added the tangent like a lazy bastard? What does this look like? Sometimes it's good just to test bad ideas. Yep, that's a bad idea, alright. So I think maybe what I have to calculate, if these velocities are opposing, so they end up canceling out. I don't know if I should turn that into angular or along the tangent. I'll try adding a scale to this. I also forgot to add that copy sign, which is just causing it to move in different directions, but wasn't the reason it's bugging. Maybe I should add this pull force to the tangent. Maybe that's the... Whoa! That's... Oh man. It's so... part of what I love about experimenting with this is just like all the weird effects you get like this. I mean, I love how none of this is traveling outside. It's still staying contained in the box. You know what? That almost actually seems like it's on the right track. Okay, I might try doing the force here. Whoa! Oh my god, this is actually really close. Holy shit. So it's swinging back and forth, albeit very badly and buggy. And I'm actually gonna need to swing something in real life to test this. Yeah, the bottom should be leading. The top here shouldn't be leading, it should be the bottom. Interesting. so the movement stops when it gets all pushed up there. Huh. That kind of worked. I feel like I'm actually making progress with this right now. I've got it sticking together. Oh man, I do feel like this rope test is a bad test though. I think I might make a little like race car or something to go over some hills and test how the joints stick together in a car that's actually having like, so then I can apply forces back and forth to it. Yeah, so I have to shift something about this velocity to the tangent. But when and how do I do it? Maybe calculate how much the velocity changes. And then do it with the tangent. I'll try that. You know what, let me try the elasticity again. I'm going to try giving it 2 times elasticity and up to 10 times. Because now that it's actually transferring... Oh god, nope. Okay, now let's try increasing the elasticity 10 times. Okay. Oh man. That's messed up. Okay. It's staying, the interesting thing is it's staying together and it is kind of waving back and forth, but Oh, it's jiggling. That's interesting.
I've been locked inside your heart-shaped box for weeks.
Alright, yeah, so I'm gonna do this in 2 steps.
Tell me that your life is better ever since I've been gone.
Actually, I'll comment this out. So what I'm gonna do, I'm gonna set v1 and v2, or maybe some new temporary variable. Anyways, I need to save the old velocity. New velocity 1. Alright, so then I'm going to compare the difference between these old and new velocities, or at least get the length. Alright, so I need to subtract the old, the new from the old. Calculate the length of that. Alright, there we go. So each of these is the length difference between each velocity before and after. So then that difference in velocity is going to get transferred into that tangent movement. So basically when velocity gets lost due to the joint's opposing forces, it's going to transfer that into angular momentum. Hopefully that'll work. We will see. Alright, so multiply this, or copy this sign, that dot product of these lengths. Alright, then we just multiply each of these, or add and multiply each of these. Alright, see how this works. I bet it's going to be glitchy as hell. Yeah, like most of the other times. Alright, so let's break down what it's doing. So it's working normal, I believe. Except for here, these ones start leading when this one should be at this point. So let me... What happens when I drop? Yeah, so this bottom part should be leading, not those.
Do I need permission to stop missing you? I surrender me to quit your energy. You've been sending signs knowing they're getting through.
I actually think I might be transferring the velocity wrong.
What is it about me? How come you can't let me go? 'Cause I've been waiting patiently, and you still got me on my toes.
Alright, so yeah, I need to scale this down at least.
Like a tornado. Gotta let me go, gotta let me go. Gotta let me go, gotta let me go.
So that, yeah, still has too much force up here. But that's actually still better. It is swinging, albeit badly. How do I get the swinging movement to be based out of right here instead of up here, though?
You can't let me go. 'Cause I've been waiting patiently, and you still got me on my toes. What I'm craving hit me like a tornado. Gotta let me go, gotta let me go. Gotta let me go, gotta let me go.
Yeah, so the top is leading right now. That's completely wrong. That's interesting. That swings forward once. How about times this dot product?
Do I need permission to stop missing you? I surrender me to quit your energy. You've been sending signs knowing they're getting through. Sending them on by.
Nope. Oh man.
What is it about me? How come you can't let me go? 'Cause I've been waiting patiently.
Yeah, so the next time I work this, I'm going to work on making a little racing test for this.
What I'm craving hit me like a tornado. Gotta let me go, gotta let me go. Gotta let me go, gotta let me go.
Alright, and it might be the inverse dot product for this. Let's try it. Okay, that's really weird.
What is it about me? How come you can't let me
Oh my god.
go? 'Cause I've been waiting patiently, and you still got me on my toes. What I'm craving hit me
Oh my god, I'm adding the different X and Y to that. Is that messing with it? Could have been. I didn't mean to do that. I think it might be because your top ball just jumps up a bit after the first frame. Yeah, I don't know about that. Also that it's locked in place. It doesn't have, this top ball doesn't have normal like velocity as all the other ones. I don't think it's that though. But that's part of the reason why I want to do a little race car test too, is it's not going to be like a messed up test like this. See, I'm not sure if this is even wrong. Like, it actually seems kind of right in my mind that the middle of it is leading. It's not the top. It's just the part where it gets stuck at the top and does not look natural. Yeah, so I don't think this difference in velocity is the way to do it. I'll shift the force around for the other balls. Yeah. I don't think it's that much though. It's only like very tiny units. I made sure that it's very close lined up. Yeah, it's 0.05 different on the y-axis. Maybe if I did this the other way around. I add the velocity of each other one. No, it does basically the same thing. Oh, actually. Oh my god, wait. Okay, that's janky, but it's still kind of better because it's not getting stuck at the top. Huh. This is some janky physics. Oh man. It just went the other way. Gotta go later. Good luck. Thanks, man. See you around. This thing has a life of its own. This would make like a good boss for a video game, trying to shoot this thing and having it like dodge your bullets and stuff. Hey, Link P. Hardcore. Yeah, I don't know. These balls are pretty soft. They're just like passing Straight through. Look at them. Oh shit, did YouTube pause again? How the hell did I get... I got from drum and bass to trap music. That's YouTube. That is YouTube. How come you wanted to code an engine in C? There's a bunch of things I wanted in an engine that I was willing to do myself. Also, I'm really interested in stuff like this joint physics that I don't really understand how it works, and I want to know how it works. And potentially have a custom system. Mostly it just gives me more control. Yeah, so it doesn't slow down when it goes up either. C is the language of the gods. Assembly is. Hey, C has inline assembly. But yeah, C is very close to assembly. That's a very nice thing, is you actually have a pretty good idea of what these are going to compile to. Well, that's one of the things that bugs the shit out of me with languages like C#, is they're built with the expectation that you just let the compiler optimize everything, and I do not think that's the way. I think optimization is up to the programmer. I can't write C code, I only break it. That's how you start, though. And I mean, hey, I've broke my code like 40 times so far in this past hour. Hopefully, in the next 50 times, I'll break it in a way that I actually think looks good. Yeah, I really cannot think, though, of another way of how to transfer this velocity across. Ever tried Sea Lion? No. Cross-platform IDE for C and C++. Maybe the velocity is getting transferred too much, and that's part of it as well. No, actually, it's still what I thought before. I think this looks really good at the beginning when it falls here. I think this is correct, with each of this gaining velocity, but then when it starts slowing down here is when it should start transferring the velocity. So like I feel like I'm like halfway there. I just need to make this somehow change into that sideways velocity. Yeah, I think I'm done working on this for now. I think I'm gonna rewrite this again the next time I do it, because I want to go back to working with just directly with the tangent. I think I'm gonna try mixing velocities, but I'm probably gonna try just converting the velocities right into the tangent movements again, that it can actually move across. If I can get that working, that should be the best, because it actually moves along where the joints can move. Anyways, when I get this working a bit better, I'm hopefully going to have time to do this one-button game jam in these next few days. I'm thinking I should, because the game I want to make for this is just a little racing game. That's why I want to do the racing test. So it's basically just a little joint of 2 circles to simulate the wheels of the race car, and then you press the space button to move forward. So hopefully be doing that in the next few days. And that should be a good little test of the game engines making a 2D game. Anyways, thanks for watching the stream today. That'll be it for now. I might boot up the stream again in like an hour, because I really want to get this working. Other than that though, I hope you enjoyed this. I'm going to be programming a lot more physics and game engine stuff in C, so be sure to stick around if you like that. Hope everyone has a good day wherever you are.